Hello everybody, welcome to my channel. In this video, I would like to talk about pipeline and column transformers. Using these two methodologies, we can organize the repetitive tasks in our data science project, such as data cleaning, data transformation, and data modeling. So it's a way that we can encapsulate most of the important processes that we would like to apply on our data. So I'm going to show you exactly how we can do this by a practical example. I'm using Airbnb dataset from Kaggle that I'm going to leave the comment. In the comments, the link to the main dataset that I got from Kaggle. So feel free to look it up and play with the data. So anyway, at the beginning, I'm going to load my main libraries, Pandas, NumPy. I'm going to use two models, which is XGBoost regressor and decision tree. And I'm going to use the tree test split. I'm going to use the mean absolute error and mean squared error in order to measure the performance of my models. And then I'm going to use simple imputer and one-hot encoder in order to categorize my data and also address missing values. And specifically, I'm going to use also the column transformer and pipeline, which I am importing from Sklearn Compose and Sklearn Pipeline. So let me see. I don't know where is BBB is coming from. Oh yeah, okay. There is an extra comment here. Okay. And the first step, we are going to read the data. So in the case that you don't know the data, this data is displaying different information of the Airbnb data in New York, which include various columns, such as the name, the host name, the neighborhood area, the neighborhood group, and specifically we are interested in the price, which is the relative price for each Airbnb observation. So as the first step, I'm going to drop duplicates and also dropping the columns, which I'm not interested to use for my predictive model. So there we go. And then specifically, I'm interested to separate actually the numeric and categorical features in my data. So here I'm going to check if the D types of my columns is float or int. They are going to be considered as numeric feature. And if the D type is object and the levels in the category variable is less than 10, we are going to consider it as a categorical feature. So in the numeric feature, if we check it out, we have also price, but I don't want to use it directly since it is our target variable. So I'm going to drop that column also. And then as the first pre-processing step, I want to check if we have any null values. As we can see, for review per month, we have around 10,000 observations, which are null. So I'm going to create the imputer, which is going to search for the values which are none, and then it's going to fill them with the value of the mean of that column. So I'm going to define it like this. And then also I'm going to define a pipeline specifically, which include a one-hot encoder for my categorical variable. So that's why I have called it cat imputer in order to apply just on the categorical variable. And then I'm going to ignore the variables which are the level is not known. So this is important when you're using you're applying your one-hot encoder on the training data and you want to replicate it directly on the test data. So it's important to keep the handle unknown as ignore in order to evitate any error which is going to occur on the new data set. So here I'm going to create a column transformer. In the column transformer, I would like to actually to aggregate these two imputers that I have defined before. One, it's a numeric imputer, which is this one, which is going to apply on the columns. That here I have defined the numeric feature for that. So here I'm going to apply the simple imputer just for the features which are numeric. And then for the categorical variable that we have defined here, which is the neighborhood group and the room type, I'm going to apply the cat imputer, which is the one hot encoder that we have defined above. So through the column transformer, I'm going to apply two transformers, which are exactly the two processes that I have defined above. And then there is a parameter that we need to specify, which is the reminder pass-through, which means that if there is any column which is not specified inside this transformer, pass it through. So don't consider it. I hope this is clear. And then after doing the pre-processing steps, I'm going to apply two specific models. One is an XGB regressor with parameters such as number of estimator 1000, the learning rate is 0.05, and the objective function is a squared error. And then also I'm going to define a decision tree with max depth 10. So I'm going to apply these two models on my data in order to be able to compare their performance. So look specifically how we are going to do this. So before applying my models, I have to specify the training data and also the target variable, which is the price, and the rest of the columns which don't include price. Here it is specifying the training and the testing dataset using 80% for the training and 20% for the test. So here we can see the columns which are dedicated to the training. So we are going to reach the most important part, that we are going to define a pipeline. First, a pipeline for my XGB model, which include a pre-process step, which is this part, that I'm going to apply the imputer, which is addressing the missing values, and the other one is the applying one hot encoder on my categorical feature. So this is the pre-processing step that I would like to apply first, and then I'm going to apply XGB model on my data. So we are going to do the same for my other model, which is a decision tree. So I'm going to define the pre-process, which exactly we have seen before, and also applying the decision tree model on my data. So as you can see, we have defined two objects, which include two steps, one for XGB model and one for decision tree. So we are going to aggregate both of them together and giving a name to both of them. One is for XGB and the other one is for decision tree. And then we are going to iterate through the objects. So for pipe in pipeline, what I'm going to do, I'm going to first fit my training data using the model which we have defined. And then we are going to use the model to predict our test data. So by doing this, what we are doing? We are doing first the pre-processing step and also using the model for the training of my data. And then we are going to get the predictions and using the KPIs such as mean absolute error and root mean square error in order to understand the performance of my model. So here I'm not going to run this cell since it's going to take a bit time. As you can see here, okay, first consider that the output of the model the objective is not to show you how these two models are performing and to tell you which one is the best. Anyway, we can see that the XGB model is performing much better, not much better, but at least it's performing better than the decision tree. And through this pipelining, we could do the same steps that we were going to do for the both models, but we organize it in more organized way, in more clean way, in order to apply on my data the same processes that I wanted to do. So first we did the pre-processing, which included the addressing the missing value and also converting my categorical variable on my data and also defining two models. So here you can include more processes that it is going to be adopted to your use case. And the sky is the limit. Just I wanted to share with you how by using pipeline and column transformer, we can improve our code readability and we can organize it in much more easier way. And I don't recommend this to do it in the time that you are doing like the pre-processing and you don't know a lot about your data. You can first apply the pre-processing step, the exploratory analysis, and then when you want to put your carry your code into the production, you can organize it by using the pipeline and the other steps which are essential for your project. I hope you learned something new. In the case that you have any doubt, please leave your questions in the comments, and I'm going to add extra references in the case that you are interested more in the material. Hope to see you soon.